Swayam Prabha. Digital India. Educated India.
Welcome to the next session on Organic Chemistry Paper 3. In the Unit 1, we are studying about nitrogen containing functional groups. In Lecture 5, we will be studying about amino compounds Part 3. I am Dr. Balaji, currently working as Associate Professor in the School of Biotechnology at Jawaharlal Nehru University. This project is sponsored by DTH Swayam Prabha, MHRD, New Delhi. The topics that will be covered in this session include preparation of secondary amines. So, here we will be looking at how secondary amines can be prepared from nitro compounds or similar compounds by reduction reactions. We will also be looking at how amino compounds, secondary amines, can be prepared from alkyl halides and how aldehydes can be converted into the secondary amines, reductive amination reaction basically. So, we will study about all these reactions. Later on, we will move on to study about the preparation of tertiary amines. So, in the tertiary amines, we will be looking at how tertiary amines can be prepared from alkyl halides, and we will also look at how aldehydes can be converted to tertiary amines, and then we will study about East-Wheeler-Clark reaction, how tertiary amines can be prepared, and finally, we will just briefly look at what are the general properties of amines. Welcome to the next session. In this session, we will be looking at preparation of secondary amines and tertiary amines. In the beginning, we will start with preparation of secondary amines. Let us look at the various methods by which how secondary amines can be prepared. We will first look at the reduction methods. So, how various functional groups can be reduced to the corresponding secondary amines we will look at. Then we will move on to how secondary amines can be prepared from alkyl halides, and also how aldehydes can be converted to secondary amines we will be looking at. Let us first look at the preparation of secondary amines from isocyanates. That means this is the reduction methods. So, we have earlier seen the cyanides can be reduced to the corresponding primary amine derivatives. So, this is what we have seen earlier. So, the reduction of cyanides gives the primary amine, but if we use the isocyanate, that is RNC, if it is reduced, then we end up with a secondary amine. So, here there is a terminal carbon. So, this carbon on reduction gives the methyl unit, and this RN part is the one which is written here. So, we have two alkyl unit, there is alkyl unit 1 and there is a methyl unit 2 attached to the nitrogen. So, this is the secondary amine. So, the primary amine generally is prepared from the nitriles directly or the cyanides, but if we use isonitriles, we end up with a secondary amine. So, the same reducing agent whatever we have used for the reduction of cyano to amino can be used here also. So, Raney nickel in the presence of hydrogen gas can be used to prepare secondary amines from the isonitriles. Iron and HCl can also be used for this particular reduction reaction. So, isocyanates can be converted to secondary amines. So, this is the reduction method. Then if we look at the preparation of secondary amines from alkyl halides, we have a couple of methods. We will look at the first method. In this one, the primary amine is reacted with the alkyl halide. So, one equivalent of a primary amine and one equivalent of an alkyl halide both react together by the loss of HX. That is, one hydrogen is lost from the ammonia unit and the X is lost from the alkyl unit, alkyl halide unit. So, we end up with the H and X combined together to give HX. So, the loss of HX leads to the formation of secondary amine. So, in other words, we have to use equimolar quantities of the primary amine and alkyl halide should be used to prepare the secondary amine. If we use a less amount of the primary amine, then what will happen is we will end up with the other side products like a tertiary amine, and the quaternary ammonium salts are generally formed. And if we use Rx in less quantities, then what happens is we end up with the lower quantities of the secondary amine. So, what we have to look here is the use of one equivalent of the amine, primary amine, and one equivalent of the alkyl halide is very important for the success or the higher yield of the secondary amine. So, using either one of the things in large excess or in less amount leads to different types of products. If you use amine in less quantity or alkyl halide in a large excess, we end up with the tertiary amine and the quaternary ammonium salt. But if we use a less amount of the alkyl halide, then what will happen is we will end up with a less amount of the secondary amine. So, this is the one thing we have to keep in mind. We have to use equimolar quantities of both the starting materials to get maximum yield. And there is another method for the preparation of secondary amines from alkyl halides. So, here we start with the aniline. So, the aniline is reacted with the alkyl halide. So, we end up with the dialkylated product. So, the dialkyl aniline is formed. This dialkyl aniline is treated with nitrous acid. We end up with the nitroso derivative, that is the para-nitroso derivative, that means para-nitroso dialkyl aniline is formed, and this on treatment with the sodium hydroxide undergoes cleavage. Here we end up with the cleavage of this particular carbon nitrogen bond between the aromatic unit and the nitrogen. We end up with the secondary amine as our final product, along with the formation of para-nitrosophenol as the byproduct. Anilines and alkyl halides can be reacted together to get the secondary amine. So, this is another method of preparing secondary amines from alkyl halides. So, we have another method in which calcium cyanamide, as written here, is treated with the sodium hydroxide to give the sodium cyanamide. So, this disodium cyanamide on treatment with the alkyl halide gives the dialkyl cyanamide. So, we have the two alkyl unit attached to the nitrogen. So, this is the dialkyl cyanamide, and this dialkyl cyanamide on hydrolysis gives corresponding secondary amines. So, this loses carbon as carbon dioxide molecule, nitrogen as ammonia. So, these two are lost in this particular reaction, and we end up with the secondary amine. So, this is another method of preparing secondary amines from alkyl halide. So, here again we are using the alkyl halide. So, we use two equivalent of the alkyl halide because there are two sodium which are present in the sodium cyanamide. So, these two sodium units are replaced by two alkyl units. So, that is the reason here we have to use two equivalents of the alkyl halide for this particular reaction to be successful. And as the last step is nothing but the hydrolysis of this particular dialkyl cyanamide. So, the next or the third method is from the aldehydes. So, the aldehydes can be treated with primary amine. When we treat a primary amine and an aldehyde, we end up with a Schiff's base or imine. So, this is the imine that is formed in this reaction. So, this imine on reduction using Raney nickel and hydrogen gives the corresponding secondary amine. So, we have one alkyl unit, we have another alkyl unit. So, two alkyl units are attached to the nitrogen atom. So, this is a secondary amine. So, here one of the alkyl unit comes from the primary amine and the other alkyl unit comes from the corresponding carbonyl compound. So, that is how we get the two alkyl units, and if we have the if one of the substituent is a aromatic unit, that means if we have the phenyl unit or other aromatic unit is present either on the amine or on the aldehyde, then we get a very good yield of the secondary amine. Let us look at the another method. Here we are going to treat, previously we have seen the reaction with alkyl halides, we also have seen the reaction with the carbonyl compound. Now, we are going to see the combination of both, that means alkyl halides and aldehydes combined together to give this particular secondary amine. So, how the reaction proceeds we are going to see. So, the benzaldehyde when treated with the primary amine, this gives the corresponding imine salt. So, this imine can be reduced to the corresponding secondary alkyl derivative. So, this is the secondary alkyl amine which is formed, and this secondary, that means here we have the benzyl unit and we have the alkyl unit here. So, this compound is called as benzyl alkyl amine. So, this is the secondary amine. So, this secondary amine can be treated with the alkyl halide. So, in this case what happens is, this hydrogen on the nitrogen is replaced by the incoming RX. So, this alkyl halides alkyl group replaces this hydrogen, and we actually end up with a tertiary amine. So, this is a tertiary amine, and this tertiary amine can be cleaved using palladium, carbon and hydrogen. So, here we end up this reaction is basically, the cleaving of this reaction is nothing but a debenzylation reaction. That means we have a C6H5 unit here and we also have a CH2 unit here. So, the C6H5 CH2 unit is combinedly called as the benzyl unit, and this benzyl unit is removed by the palladium, carbon and hydrogen reduction. So, that is why this is called a debenzylation reaction, and this debenzylation reaction now gives the corresponding diamino. That means a secondary amine or the dialkyl amine is formed. So, one of the R group comes from the starting material, that is the primary amine. So, this R group comes from the alkyl primary amine, and the second R group comes from the alkyl halide. So, this is how we end up with the 2 alkyl units on the nitrogen atom. So, that is how this is a secondary amine, and this is a different method. So, here we are using an aldehyde and an amine to give a imine, and this imine is then reduced to the corresponding secondary amine. The secondary amine reacted with the alkyl halide to give the tertiary amine. Debenzylation of this particular tertiary amine using palladium, carbon and hydrogen leads to the secondary amine. So, although we will be looking at why we have to introduce a benzaldehyde unit and then we have to remove it here, but the use of benzaldehyde unit is used as a masking unit. Otherwise, if we are using a primary amine and alkyl halide, they both can also be reacted together, but in this particular case we actually end up with a multiple product like secondary amine, tertiary amine, quaternary ammonium salt, all those things will be formed. So, to avoid those kind of side reactions, we generally use here benzaldehyde unit. In this particular reaction is used as a blocking or a temporary blocking unit to control the substitution on this nitrogen atom. So, this is very similar to the phthalimide reaction. So, in the phthalimide reaction, what we do is we are actually using the alkyl halide with potassium phthalimide. So, that stops the reaction at the primary stage itself. So, primary amines can be prepared using that phthalimide reaction, and here when we use benzaldehyde and the primary amine, we can get the secondary amine. So, this is another way of making selectively one particular product, that is the secondary amine. So, these reactions are called selective preparation methods. So, let us move on to the next one, which is the preparation of tertiary amines. So, the first one is preparation of preparation of tertiary amines from alkyl halides. So, 3 equivalents of alkyl halides when treated with ammonia gives the corresponding tertiary amines. So, here we can use the ethanolic ammonia solution. As we have seen earlier also, for the preparation of primary and the secondary amine, the number of equivalents of the alkyl halide used is very crucial for the success of this reaction. So, here if we use exactly 3 equivalents of alkyl halide and 1 unit or 1 equivalence of ammonia, we end up with the tertiary amine as the major product. We have another method in which a carbonyl compound can be converted to the corresponding tertiary amine. So, here we start with the secondary amine. A secondary amine is reacted with the carbonyl compound. Here we are treating it with the corresponding aldehyde compound. this aldehyde compound actually has a one particular hydrogen atom. That means there is a alpha hydrogen atom, at least one alpha hydrogen atom should be present for this particular reaction. So, when a secondary amine is reacted with the carbonyl compound containing one alpha hydrogen, we end up with a enamine formation. So, if we are using a primary amine and an aldehyde compound, we end up with imine. So, if we use a primary amine and a aldehyde compound, we end up with a imine. If we use a secondary amine with a aldehyde containing a alpha hydrogen atom, we end up with a enamine. So, we have a ene unit, that is the double bond is present here. We have a amine unit present here. So, this is called the ene and amine both present in this molecule. So, this is called the enamine derivative. So, this enamine derivative can be reduced using Raney nickel. So, here the double bond is reduced. So, we end up with a tertiary amine. So, this is one way of preparing tertiary amine. Now, instead of secondary amine, we can also start from a primary amine to get the corresponding tertiary amine. So, how can we do that reaction? So, what we have to do is, when we treat a primary amine with the corresponding carbonyl compound, as I have mentioned, the primary amine reacting with an aldehyde gives a imine derivative. So, this is the first product that will be intermediate that will be formed in this reaction. So, this imine on reduction using Raney nickel and hydrogen gives the secondary amine. So, this secondary amine now becomes the starting material for our next set of reaction. So, this secondary amine can react with one more equivalence of the corresponding carbonyl compound which is having the alpha hydrogen. So, we end up with the enamine, and the reduction of that enamine using Raney nickel and hydrogen will produce the tertiary amine. So, that way we can directly use a secondary amine to prepare a tertiary amine, or in a additional step we can also use a primary amine to prepare a tertiary amine. So, this reaction can be used from either primary amine or secondary amine to prepare the final tertiary amine. And of course, we can also use ammonia in large excess. In that case also we will end up with the tertiary amine. So, these are all the various ways by which we can prepare tertiary amine from the carbonyl compound and either primary amine, secondary amine or ammonia. The next one is a Eschweiler-Clark reaction. So, here we are going to use the preparation of tertiary amine from a secondary amine. So, the secondary amine is reacted with formaldehyde. Instead of any aldehyde, we are using formaldehyde in the presence of formic acid. So, this reaction is a very specific reaction. So, in this particular reaction we end up with the N alkyl, that is one of the unit is mainly the tertiary methylamine. So, this reaction is very specific for the preparation of tertiary methylamines, because we are using a formaldehyde. Formaldehyde has one carbon unit. So, this one carbon unit is attached to the nitrogen directly. So, we end up with a methyl unit on final reduction. So, how the reaction actually proceeds is basically we have a formate anion formed, because we are using a formic acid in this particular reaction. So, there is a formate anion which is formed in this reaction, which is the hydride donor. That means H minus group is added, and this is used to reduce the imine or the iminium salt that is formed in this reaction. So, a secondary amine and the acid formaldehyde gives the imine salt. This imine salt is reduced by this particular hydride donor, that is the formate anion. And then if we look at the overall process is basically a reductive amination reaction. That means we have a carbonyl unit, we have the amino unit. So, these two are condensed together to give the corresponding amino derivative. So, reduction and amination both takes place. So, this is a reductive amination reaction, and here we are using formaldehyde as one of the reagents. So, this is ending up with the methyl derivative, that means the tertiary methyl amines are formed. So this is a very specific reaction for the preparation of tertiary methyl amines. Let us look at the overview of the secondary amine and the tertiary amine preparation. We have seen the secondary amine preparation from the isonitriles, that means isocyanide on reduction gives the corresponding secondary amines. So when we are using the reduction reaction, the reaction is actually sensitive to other functional groups also, that means alkenes and other groups which can be reduced are also affected in this particular reaction. And for better yield we generally use ranane nickel and hydrogen. Acid and hydrogen, that is iron HCl conditions are not generally employed in this particular reaction. So ranane nickel and hydrogen gives a very good yield for this particular transformation. And we also have seen about the alkyl halide to amine reduction. So here aniline followed by reaction with the nitrous acid to give the secondary amine is one reaction we have seen. We can also use sodium cyanamide, or we can also use ammonia and primary amine to prepare the secondary amine. So the better method is for aniline reaction of alkyl halides with aniline. So that is the dialkyl aniline is formed, which was treated with the nitrous acid to give the para-nitroso derivative, which on hydrolysis gives the corresponding secondary amine. So here we get exclusively the secondary amine only, there is no side products formed in this reaction. And we have also seen about the carbonyl reduction to amines. So in the case of carbonyl to secondary amines, we first form the imine, and the formed imine is reduced to the secondary amine by the reducing agent. And if we are getting an enamine, then the reduction of the enamine gives the tertiary amine. So this is the difference between secondary amine formation and the tertiary amine formation. If we use primary amine, we end up with a primary amine with the carbonyl compound, we get imine. So the reduction of this imine gives the secondary amine. And if we start with the secondary amine, reaction with the carbonyl compound containing alpha hydrogen gives the enamine derivative. Reduction of this enamine derivative gives the tertiary amine. So these are all the two methods by which a carbonyl compound can be converted to either secondary or tertiary amine. Let us look at the general properties of amines. So here we are just going to look at what are the physical and few chemical properties of amines. Amines are having a lower boiling point than the alcohols, but they have higher boiling point than alkanes, because if you look at RH, the boiling point of alkanes are lesser than the boiling point of amines, which is in turn lesser than the boiling point of alcohols. So the reason for this is basically we have a hydrogen bonding, weak hydrogen bonding possible in the case of amines. A strong hydrogen bonding is possible in the case of alcohols. So the alcohols have a very high boiling point, followed by amines which are having a lesser boiling point, whereas alkane have no hydrogen bonding. So that is the reason alkanes have a very low boiling point. So this is how we can compare the boiling points of alkane, amines and alcohols. And of course, if you look at the lower members, that is amines with less than 6 carbon atoms, they are highly soluble in water. Because of the hydrogen bonding, the lower members of the amines are soluble in water, and they have a lone pair on nitrogen. So that is the reason they are basic in nature. So if you look at the carbonyl compounds are neutral. Carboxylic acid is acidic in nature, or phenols are acidic in nature, whereas amines are basic in nature because they have the lone pair of electrons on the nitrogen. So these are basic compounds. Since the amines are basic, what they can do is they generally react with both inorganic acids and organic acids. So when they react with inorganic acid, they give corresponding salt, and when they react with organic acid, they form amides. We will look at the reactions of amines elaborately in the next session. amines also react with acid chlorides or anhydrate to give corresponding carboxamides. They react with alkyl halides to give alkyl substituted amines. So, if a primary amine reacts with an alkyl halide, we end up with a secondary amine. So, we have secondary amine, and the secondary amine when reacts with the alkyl halide gives the tertiary amine. So, the substitution on nitrogen increases by 1 whenever amine is treated with an alkyl halide. And when we heat an amine salt, especially the quaternary ammonium salt, the smallest alkyl group is actually eliminated first. This is used for the estimation of N-methyl groups in the case of alkaloids. When we look at the reaction of amines, we will be looking at, this is called the Hoffman degradation method. So, here we will be looking at Hoffman exhaustive methylation followed by degradation. So, we will be looking at our Hoffman elimination method, this is also called as. We will study elaborately about this particular reaction. Let us recap in the summary what we have studied so far. We have studied about various preparations of secondary amines. We have studied how secondary amines can be prepared from alkyl halides. We also have studied about how reduction reaction can be employed to prepare secondary amines, how aldehydes can be converted to secondary amines. All these reactions we have seen. Then we moved on to study the preparation of tertiary amines. So, how tertiary amines can be prepared from alkyl halides, like how ammonia and alkyl halides react together to give tertiary amines we have seen. We have also seen about how aldehydes can be converted to tertiary amines. Finally, we studied about Eschweiler-Clark reactions, how tertiary amines can be prepared. And we also compared the synthesis method of secondary amines and tertiary amines. What is a specific method for the preparation of secondary amines? What are some specific method for the preparation of tertiary amines we have seen. And finally, we have also studied about some general properties of amines, few physical properties and some of the basic nature of the amines we have studied. With that, we conclude this session. Thank you.